Okay, in this movie I'm just going to explain the basics of function overloading or method overloading. This is an advanced concept, but something we're going to run into fairly quickly when we start dealing with objects. And it's good to see that it actually works with functions as well, which means you don't have to be object-oriented to use function overloading. So let's create a simple function. Okay, this function is going to return an integer. The function is going to be called greatest, or how about greater? And it's going to take two integers for arguments, value 1 and value 2. And the purpose of this function is to determine which of the two numbers is greater and return it. So I'm just going to write a condition statement. This is a very simple condition statement, an if statement with an else. It doesn't require me to use curly braces. I can use the shorthand. As long as I only have a single statement, I don't need the curly braces. I'm sure you've probably covered this in JavaScript. So I'm going to say if value 1 is greater than value 2, then I will return value 1. Now you might think I should write an else here, else return value 2, but that's actually pointless. If value 1 was greater than value 2, we've already returned. So if not, we just return value 2. So take a look at that function for a moment. I'll just put the curly braces in for a second and remind you that the curly braces are not required if you have a single argument. Sorry, a single statement. It's just shorthand and you can live without them. But be very careful when you're writing that kind of code. If you add a second statement underneath, then the curly braces are required. So looking at this, I think I'll just leave the curly braces in for clarity this time, but remember they're not necessary in this situation. If value 1 is greater than value 2, we'll return value 1. So that'll take us right back to wherever we came from. If we get to here, obviously this was not true, so this has to be true, and we'll return value 2. All right, so let's call that function from main, invoke it. What we're going to do is we're going to create an integer. We'll call it answer, and we'll say it's equal to, and I'm just going to call this with just two arbitrary numbers. We're going to call greater with the numbers 10 and 20. And then I'm simply going to see out the answer. And add a new line. All right, so let's take a quick look at this. I'm going to call greater, store the answer, which should be 20, and then output it. Let's see what happens when I run that. Control F5. And you can see the answer is indeed 20. Okay, so this function is working. Now imagine I wanted to call this function, only this time I'd like to call it with two floats. Okay, so I'd like to know which number is larger, so I'm going to create a float. I'll call it result, and I'll say it's equal to greater, and I'm going to pass 23.78f and 12.34f. Remember, the f is a suffix. It means we're passing floats in this case. So take a look at that. Looks pretty straightforward. I'm passing a float. I'm passing a float. Should come back with this one because it's larger and store it in result. Let's do a build. I'm just going to rebuild this because I want you to see the warnings that I get. So it's warning me that the argument, the thing being passed to the function, is being converted from a float to an integer. So there's a possible loss of data. And here I'm doing the same thing on the second argument, conversion from int to float. What it's complaining about, if I click on one of these, it's complaining about this. It's saying, Look, the function you're calling takes two integers, this portion of the number. It has no understanding of this, the decimal point and beyond. So truncation of data means this data is going to be lost. And actually the return type is also an integer from that function. So there's no way I'm going to get back what I'm looking for. So let's just take a look at what the answer is. So I'm going to output the result this time. So we get the float version. And hit Control F5. And you'll see the answer is 23. All right, and there's a very important point I wanted to get across here. That when you're dealing with integers, integers don't round up. Most people would look at this and think that should be rounded up to 24. Integers do not round up to 24 or to 23. If it was 23.13, it wouldn't round down to 23. They don't round up or down. They don't understand. Integers have no understanding of this, so it's just completely ignored. Okay, so with that in mind, let's take a look at our code. What I like about what I'm trying to do here is I'm calling a function with the same name, greater. It's suggesting I'm going to return the greater of the two numbers, but if I want to be consistent in my code and I want to use the same name for something, I've got a problem because C++ says you can't have two functions with the same name. And that's not just true of C++, that's true of C#, Java, etc. However, there is a rule that says you can have two functions with the same name as long as the argument list is different. The argument list, these things, as long as it's different, not here where you're calling the function, but here where you're creating the function, the signature. Okay, so I'm going to copy this function in its entirety, and I'm going to paste it underneath the existing function. Now you look at that, I've got the same function duplicated. If I try to build this, it's going to give me the standard sort of error where it's basically saying function integer greater int already has a body. In other words, it already exists. And you can't have two functions with exactly the same name because that's ambiguous. I don't understand. However, if I modify either of these functions, and I'll just go to the top one, so that this becomes a float, and this becomes a float, and the return type becomes a float, I'd like you to note that this function signature differs from this function signature. Okay, now it's very important when we're talking about overloading, the return type is ignored. We don't look at the return type. There's a good reason for this. I'm not going to go into it now. We're going to wait till we hit classes, but we don't look at the return type. So we look at the function name, both the same. We look at the argument list. This function takes two floats. This function takes two integers. Your compiler can tell them apart. It says, okay, when you're calling a function, say from main here, I can see in this case, you're calling the greater function that has two integers. And I have one, so that's okay. And in this case, you're calling the greater function that has two floats, and I have one, and that's okay. And as you will see, there'll be no problem when I go to run this. And the output is 23.78. So it's working exactly the way you would anticipate. So function overloading, just a basic definition, is having two functions, two or more functions with the same name but different argument lists. This can be incredibly useful. Simply for consistency in your code, it's obvious I'm creating a function that's called greater, and it could be a function called add or subtract, which in reality is what the add, the plus sign does, and the subtract sign, the minus sign does. They actually are function calls, and they do overload. They work with different types. Now I can have more of these, just to sort of, I folded those away so I get some screen real estate. I could return an integer from a function called greater, And that function could take one int, I'll just call it x, and another float, and we'll call that y, just to be different. And I'd like you to notice that I'm just going to return, well, here, I'll just copy the code here. I might as well do it the hard way because, or the long way, because I've already got the code. So I'm just going to paste it in here, and I'll change this to value 1 and this to value 2. Now note that I have 3 different versions of the exact same function. I have one version that takes 2 floats, I have another one that takes 2 integers, and I have another one that takes a float and an integer. Now the difference there is that the compiler can easily tell this one, when you call it, you pass 2 floats. This one, when you call it, you pass 2 ints. As long as you pass an integer here and a float here, it'll be able to determine which version of the greater function to use. Now this isn't limited to having just 2 arguments. Functions can be different in any way in the argument list. So one of the greater functions could just have 1 argument, or one could have 3, and they can be mixed up any way you like. As long as you do not have 2 that have identical argument lists and the same name, then you're meeting the requirements for function overloading. Okay, the last thing I want to touch on here, and by the way, we will be covering this in much more detail in class. I just want to touch on the fact that you've got to be careful how you call these functions if they're overloaded, because you can run into some ambiguous functionality. In the first case here, where I call greater with 10 and 20, what if I called this, for example, with, what if I called this with, screen capture issues there. What if I called this with 2 doubles? So like 10.34 and 20.77, just arbitrary values. Now I'm getting a red squiggly under greater. It's complaining. It's saying something's up. Let's find out what the problem is. Now remember, I do not have a version of the function greater that takes 2 doubles. I could create one, then this problem would go away. Let's see what happens when I try to build this. Okay, this is what I'm concerned about with right here. There's a warning over here, conversion from float to int. That's to do with that function that I created that had 1 int and 1 float. Let's not worry about that. Here's the ambiguity I'm worried about. The problem is with the function greater, and it says an ambiguous call to overloaded function. And what it's telling you is, look, you don't have a version of this function that takes 2 doubles. So I could use the version that converts one of the doubles to an int and the other to a float. Or I could use the version that converts both doubles to an int. As a human picking this, I wouldn't have chose that one and I wouldn't have chose that one. I would likely choose this one, which is going to convert the doubles to floats. Both doubles become floats. That's going to give me the most accurate result. But here's the issue. This is not a human being. This is a computer, and a computer looks at this and says it could be this, could be this, could be this. That's ambiguous. No way am I going to execute this code. So the only real solution to this is to create a version of the function that takes 2 doubles, or you can go to your code and you can say, you know what? I'm going to make that a float, and I'm going to make that a float. That solves the problem. Or if you wanted to use the integer version for whatever reason, you can use a method called casting, where inside parentheses you type in the data type. So I want you to be an int, and I want you to be an int, and now the function can be called, and both of these numbers have been truncated. They've lost data, but they're converted to an integer. Now I've given you more information than I intended to in this video. I've touched on a few things here. This is called casting, type casting, which is something we'll do throughout the semester. And I've actually shown you variations of a function beyond where I initially planned to in this video, but hopefully good for reference. Let's just review the rules of function overloading and what it is. So function overloading simply means that we have more than one function with the same name. In this case, I have 3. Function overloading says you can have functions with the same name as long as the argument lists are different. So let's take a look at the argument list. This one takes 2 floats. This one takes 2 ints, so they're different. This one takes an int and a float, so it's different. All 3 of these are different. The compiler can try to determine which one you're using based on the arguments you pass, and this meets the requirements for function overloading. As a reminder, the return type of your function is not evaluated when we talk about overloading a function. The return type is irrelevant. It doesn't matter. This is never used when the compiler is trying to figure out which version of a function you want to use. And that's it.